Hello students, today we are going to cover following three topics in laws of motion, Newton's equations of motion. We are going to use graph. So using graphical method, there are three equations of motion. First is V is equal to U plus AT, S is equal to UT plus half AT square, and V square is equal to U square plus 2AS. Then we are going to cover uniform circular motion, and finally we are going to test through questions. We are going to attempt some test questions. So let's start with V is equal to U plus AT, Newton's equations of motion. So first equation of motion is V is equal to U plus AT. For that we are going to use graph. So let's draw a graph. This is y-axis. Let's draw x-axis. Now suppose there is a body that moves from point A to point B. Point A to point B. Now that body has initial velocity as u and final velocity as v. Now let's draw a line parallel to y-axis. Now this is x-axis is time t. Origin is O. And let's draw a line parallel to x-axis from point V. Let that point be C. So this B point is equal to the C point. So velocity can be C. Now let's draw a line parallel to x-axis from point A. Let it cut y-axis at point D. And let it intersect, let the line parallel to y-axis intersect line x-axis at point, say, E. Now we know that acceleration is nothing but change in velocity with respect to time. Now here in this equation which we have to derive, v is equal to final velocity, u is initial velocity, a is acceleration and t is time. So now acceleration we know is nothing but change in velocity with respect to time. So what is change in velocity? V minus u with respect to time t. But if you look at this graph, this is nothing but OC minus OA, right? With respect to time t. This is equals to EB minus ED with respect to time t. This OC is nothing but equal to EB minus ED. This is nothing but equal to BD upon time t. This is time t here on x-axis. Now this is nothing but equal to slope. BD upon t is nothing equal to slope of this line AB. So slope of this velocity time graph gives us acceleration. We are going to recall this. If we remember this, acceleration is nothing but slope of velocity time graph. So this is nothing but v minus u upon t. Therefore, at is equal to v minus u, or we can say v is equal to u plus at. This is first equation motion. So through this graph, we are able to derive from the slope of this graph, so from the slope of this line AB, we are able to derive acceleration, and from acceleration we are able to derive the formula v is equal to u plus at. Now let's move on to the next equation of motion. Second equation of motion is s is equal to ut plus half at square, where u is the initial velocity, t is time, a is acceleration, and s is the distance travelled. So we are going to define the relationship between distance covered or displacement with respect to time. So if you look at this graph, we know that area of quadrangle OABE is nothing but this result. If we recall, we have studied or S is equal to area of triangle ADB plus area of rectangle OADE. Now area of triangle ADB is half into base into height. So base is time t, height is BD, plus area of rectangle OADE is nothing but length into breadth. So length is t and breadth is OA. So we know that BD is nothing but V minus U plus T into U. OA is nothing but U. Now we know that V is equal to, since V is equal to U plus AT, AT is equal to V minus U. Therefore, S is equal to half into AT into T, by keeping this here, plus UT. So this is nothing but UT plus half AT square. So this is second equation of motion, which gives us the relationship between distance and time. Now let's move on to the third equation of motion. V square is equal to U square plus 2AS, where V is final velocity, U is initial velocity, A is acceleration, and S is distance travelled. So we are going to define the relationship between velocity and displacement here. See, this is a straight line, so the distance will be same as velocity. and we know the direction that the car moved from point A to point B. So now we know that distance is nothing but area of quadrangle, or we can say trapezium is the distance traveled, OABE. Area of trapezium, OABE. This is nothing but half into sum of parallel sides, which is OA plus EB, into distance between them, which is nothing AD, or you can say time t. So half into OA is nothing but U plus EB is nothing but V into AD is nothing but T. Since we know V is equal to U plus AT, therefore T is equal to V minus U upon A. Keeping this value here, therefore S is equal to half U plus V, because we have to find out the relationship between velocity and displacement. So we have to remove time from here, V minus U upon A. This is nothing but 2AS. If we take this 2 and A up with S, V square minus U square. Therefore, V square is equal to U square plus 2AS. Now let's move on to uniform circular motion. Suppose this is a rectangle and I move my pen from here and come back to the original position, tracking the path of the rectangle. So how many times have I changed the direction? 4 times. Similarly, this is a hexagon, and how many times I have changed the direction? If I move along a hexagon, 6 times. Similarly, in an octagon, I will change the direction 8 times. And how many times will I change the direction if I move along the circle? If this polygon becomes infinite sides polygon. That means I'll change my direction infinite times. So this becomes a circle. Now, suppose this is a disc D. It's a circle, suppose, and it's on an axis, it's moving on an axis. I keep a coin here, 5 rupee coin, say. Now, if I move it along the axis, if I move the disc along the axis at a very high speed, the coin, it will try to throw off the coin. So the coin will be thrown off in direction perpendicular to the radius. This is point O. If I keep the coin here, then coin will be thrown in this direction. If I keep the coin here, then coin will be thrown in this direction. So it is always perpendicular to the radius. That means the direction of the coin is always changing. So if a particle moves on a circular path, its direction is always changing. So if it is moving at a constant speed and its direction is always changing, that means what? Constant speed and direction is changing. So if we recall, this is nothing but velocity. Constant speed, direction is changing, that means change in velocity. I'll write it here. So, what is the speed now? Speed is nothing but distance travelled upon time taken. Distance is the particle starts from here and comes back to the original position following the circular path. It will cover 2 pi r distance, which is nothing but circumference of the circle, and time taken is t. But what is the velocity? Velocity will be 0 because displacement is 0. It started from the same point and came back to the same point. Displacement was 0, so velocity will be 0. So here the particle is moving in a uniform circular motion, and this is what we have to understand, that the direction of the particle is changing, though the speed is constant. Since the direction is changing at every point, it is moving with changing velocity. So now let's test ourselves through some questions. So the first question is, an athlete is running on a circular track. He runs a distance of 400 meter in 25 seconds. So solution 1. Before returning to his original position, what is his average speed and velocity? So this is the movement in a circular path, and we know that average speed is nothing but total distance travelled upon time taken. So speed is nothing but, average speed is nothing but total distance travelled, which is 2 pi r upon time taken t, which is 400 upon 25 seconds and 400 meter. So this is nothing but 16 meter per second. And what is the velocity? We just discussed this in our last session, in this session only, but last topic. It will be 0 because displacement is 0. Let's move on to the second question. An aeroplane taxis on the runway for 30 seconds with an acceleration of 3.2 meter per second square. How much distance would it have covered on the runway? So here the distance travelled, S distance, is equal to question. And what is the time taken? 30 seconds. What is the acceleration? 3.2 meter per second square. So if we remember our formulas, the three equations of motion, S is equal to, if we apply the formula, S is equal to ut plus half at square, we will be able to find out distance travelled. So u is 0 because aeroplane taxis on the runway, so initial velocity is 0, plus half, a is nothing but 3.2, and t is nothing but 30 square. T square is nothing but 30 square. This comes out to be 1440 meter. Let's move on to the third question. A kangaroo can jump 2.5 meter vertically. What must be the initial velocity of the kangaroo? Here the kangaroo is here at point A. It moves to point B, covering a distance of 2.5 meter. Now let the initial velocity be u. But what is final velocity? 0, because when it reaches to the top, it falls down after that, because it doesn't go further up. So v is equal to 0, u is equal to quotient, s is equal to 2.5 meter, and a is equal to quotient. But what is a here? Acceleration. Acceleration will be equal to nothing but g, gravity. So it is moving against the gravity. So acceleration will be minus g. So if we apply the formula, s is equal to, v square is equal to u square plus 2as, then we know that v is 0, u square minus 2gs. Instead of a, we are going to put minus g, because see, it's moving up, so it is acting against the gravity. So the acceleration is opposite to the direction of velocity, negative acceleration. So u square is equal to 2gs, which is nothing but, we know g is nothing but 9.8 meter per second square. We have studied this in our previous class. Into s is 2.5. So u will be around, u square will be 49. So u will be around 7 meter per second. Let's move on to the fourth question. A motorboat starts from rest. So that means u is equal to 0 and moves with uniform acceleration. If it attains the velocity of 15 meter per second in 5 seconds, that means v is equal to 15, t is equal to 5. Calculate the acceleration and the distance travelled. A is equal to quotient and distance travelled s is equal to quotient in that time. So now we know that v is equal to ut, first equation of motion. So this is nothing but 15 is equal to 0 plus a into time t is 5. Therefore, a is equal to 3 meter per second square. Now what is the distance travelled in that time? We know that s is equal to ut plus half at square. This is u is 0, so this is half at square, which is nothing but half into 3. We just found out a, 3, and time t is 5 square. This comes out to be 37.5 meter. So distance travelled is 37.5 meter. Now let's move on to our next topic. In our next session, we'll move to our next topic, which is Newton's laws of motion. Till then, goodbye.